Hello, Advanced Math. Hey, you've made it here. The last one for this part. Congratulations, those who when you got here. Hopefully this one goes well for you. Partial fraction decomposition. This is not anything in the book, but something I wanted to cover. You could see in Algebra 2 or college algebra, sorry, and just give you a very basic introduction to it. It can go into a lot more complex things. A lot of upper-level mathematics may show up as well. So I just want to give you a little introduction to it. It doesn't sound too exciting, partial fraction decomposition, but it's basically finding the add-ins to a rational expression. Sounds like fun, right? Well, basically, what fractions add to a sum? So if you had, let's say you had 5/6. Now we're going to be using variables and polynomials. You could say, okay, 5/6, that could be 2/6 plus 3/6. Okay, 2 plus 3 is 5. So finding the things that could add to it. So obviously 2/6, that could be 1/3 plus 1/2. So 1/3 and 1/2 add to 5/6. So finding the parts that add to a fraction. Okay, this does have some usefulness in higher level math, but mostly you can see it in college algebra. I want you to be prepared for that. Okay, it can be used. You can use a system of equations to solve it. We're not going to be using that approach today, though. So these notes are in the shared folder. What we have here, we have this fraction. We want to find out, okay, what parts add to this fraction. And the first thing we have to check is we want the degree of the top to be less than the degree of bottom. And if that's not the case, you have to actually use long division to divide a factor out. Okay, and we'll see that here on the third set of notes here. Okay, you notice these are equal. That means we can divide this into that one, and then we'll have something left over that we'll work with. Okay, so in this case, this is the degree of 1. This has a degree of 2, the largest exponents. The first thing we're going to do is we're going to factor the bottom. So this right here we're going to factor. So we get negative 5x plus 4 over x times the quantity x minus 1. And these factors tell us the parts, okay? So we can say, okay, I want something over x plus something else over x minus 1. So we are going to split up the factors. Okay, a over x plus b over x plus 1. And that should equal negative 5x plus 4. Okay. So this a and this b here, the a and the b are just numbers you are going to use to represent the numerators. Okay. So these are just variables. We're always going to use a and b, or you could use c if you have 3. Variables to represent the numerators. Okay, so a over x plus b over x minus 1, we know that should equal negative 5x plus 4. Now, since we split these up, the common denominator is x times x minus 1. Okay, so this is the key point here. What we're going to do next is I'm going to take a. If I need this denominator, I'm going to take a times x minus 1 plus b times x, and that should equal my numerator, negative 5x plus 4. Okay? So what we did is multiply each numerator by the other denominators. If you have more than one, you'd have to use more than one there. Okay, multiply each numerator by the other denominator. So a times x minus 1 plus b times x has to equal negative 5x plus 4. I am going to get pretty tight with this, so I'm going to move to another sheet of paper. So I have a times x minus 1 plus b times x has to equal negative 5x plus 4. What we're going to do is we're going to cancel off either the a or the b. So I'm going to start with the a. So we're going to cancel off the a. So in order to do that, I'm going to let x equal 1 because that gives me a 0. So that gives me a 0 for the a part. So I'm going to let x equal 1. So what I have is a times 1 minus 1 plus b times 1 equals negative 5 times 1 plus 4. So this is a times 0 plus b equals negative 5 plus 4. A times 0 is gone, and you get b equals negative 1. So there's your b value. So in order to get rid of the a, I said, okay, if I want to get rid of the a, I'm just going to let x equals 1. That gives me a 0 here. 0 times a is 0. But I have to put the 1 in all the other spots as well. So now let's go back and let's do that with the b. So if I want to get the b away from itself, I'm going to let x equal 0 in this case. So then I get a times 0 minus 1 plus b times 0 equals negative 5 times 0 plus 4. So that's gone. This is going to be negative 1a equals 4, so a has to equal negative 4. So there's your a and b going back to this right here. Let me show you that. There's your a and b. So a has to be negative 4, b has to be negative 1. Those are the numbers that go up there. So your answer would be a was negative 4, so negative 4 over x plus negative 1 over x minus 1. Or you can write it negative 4 over x minus 1 over x minus 1. Either one of those would work. But that is where your answer is. Those are the two partial fractions. Those are the fractions that if you add these or subtract these in this case together, you should end up with this part right here. Okay? So let's do that again here. A little bit quicker now. Factor the bottom, x plus 4 times x plus 5. So I get a over x plus 4 plus b over x plus 5 has to equal that. So I take a. If I'm adding these together, I need a common denominator. So a times all the other denominators. A times x plus 5 plus b times x plus 4. That has to equal this numerator right there. Has to equal 3x plus 10. Okay, so let's get rid of the a first. X needs to be the number that makes this equal 0. So in this case, x has to equal negative 5. So let x equal negative 5. So this would be a times negative 5 plus 5 is 0, plus b times negative 5 plus 4 is negative 1, equals 3 times negative 5, that's negative 15 plus 10. So we get negative b equals negative 5, so b equals 5. There's my b value for that. Okay, so there I got rid of the a and I solved for b. Now I'm going to get rid of the b and I'm going to solve for a. So in order to get rid of the b, I need a number here that makes this equal 0. So in this case, x is going to be negative 4. So a times negative 4 plus 5 is 1, plus b times negative 4 plus 4 is 0, equals 3 times negative 4, which is negative 12, plus 10. So a is going to equal negative 2. So your final answer is you're going to put these back up here. You get negative 2 over x plus 4 plus 5 over x plus 5. You do not reduce those 5s because it's 5 over x plus 5. It's not 5 over 5. It's 5 over the quantity x plus 5. Okay. When you get to repeated factors, so when I factor this bottom down here, I get x plus 3 times x plus 3, which can be written as x plus 3 squared. If you have that, you still are going to have two parts to your fraction. And how it's written is you're going to say, okay, a over x plus 3 plus b over x plus 3 squared. Okay, so you're going to put one factor here, and you're going to put both factors underneath the other one. Okay, now remember, this is your common denominator, which the b already has. So in this case, you do not multiply the b times another x plus 3. That would give you 3 of them on the bottom. So the a gets multiplied by x plus 3. We're just going to add the b, and that should equal negative 7x minus 15. So a times x plus 3 plus b should equal negative 7x plus 15. That's the numerator coming from over there. So let's let x equal negative 3. So a times 0 plus b equals negative 7 times negative 3 is 21. 21 and minus 15 equals 6. So we get b equals 6 off this. Okay. Now, what do we do for the a? Okay. I've got about 5 minutes before you guys start logging on. So see if I can get these two examples done here for you. So negative 3. So let's just pick another number for x. We know b is 6. Okay. Let's do it that way. So let's pick another easy number for x. So let's say, okay, x is going to equal 0. So I just picked that because it's easy to work with. So it's going to be a times 3 plus, we know b is 6, equals negative 7 times 0 is 0, so negative 7, that's going to be negative 15. So 3a plus 6 equals negative 15. Solve for that. 3a equals negative 21, so a equals negative 7. So we get negative 7 over x plus 3 plus 6 over x plus 3 squared. Okay. So when you don't have another variable that you can cancel off, like this b doesn't have an x because it already has the denominator that we had here, then you just pick another number, usually 0 or something that's going to be easy to work with, something that doesn't cancel off that a. Okay. So I factor this bottom one here. This factors into 5x plus 2 squared. 5x plus 2 squared. So I'm going to get a over 5x plus 2 plus b over 5x plus 2 squared. So a has to be taken times 5x plus 2 plus b, and that should equal 20x plus 9. Okay. So let's let x equal negative 2/5. That's the 0 for there. So we get a times 0 plus b equals 20 times negative 2/5. That should be 8, negative 8. 5 goes into 20 4 times 4 times 2 is 8. So negative 8 plus 9. So I get b to equal 1. So we know b has to be 1. Now let's pick x equals 0. This would be a times 2 plus 1 equals 9. 20 times 0, 0, 0 plus 9 is 9. So 2a equals 8, so a equals 4. So a is 4, b is 1, so we get 4 over 5x plus 2 plus 1 over 5x plus 2 squared. There are your partial fractions. Okay, those two would add up to what you have there once you got your common denominator, added them together. Okay, the last two examples here, you notice that the degrees are equal, and you actually have to start here with long division. Yay, our favorites. So I'm going to need more room than just this little bit for this, so this one I'll probably move to the back side of this. Okay, so negative 2x squared plus 4x plus 14 divided by x squared minus 6x plus 5. So x squared minus 6x plus 5 going into negative 2x squared plus 4x plus 14. Since there is an equal degree up here, that means there's a whole number that goes into that. So what you do is you take this part divided by this part. So the inside divided by the outside. So if I take negative 2x squared divided by x squared, I get negative 2. That's what goes up here, negative 2. I'm going to take that times my divisor, x squared minus 6x plus 5. We've done this before. So negative 2x squared plus 12x minus 10. And we subtract each of those. Okay, make sure you subtract. So if I'm subtracting a negative, that goes to a plus. Subtracting a positive, that goes to a negative. You change your signs. Now we can simplify. First one should cancel off. 4 minus 12 is negative 8x plus 24. And now this is our remainder, because so our problem becomes negative 2 plus negative 8x plus 24 over x squared minus 6x plus 5. Okay, and this is the part that we use our partial fractions on. So we had a whole number we could take out of there, and now we have this part to do. So we're going to factor the bottom. So we get negative 2 plus, this factors into x minus 5 times x minus 1. So it's plus a over x minus 5 plus b over x minus 1. Now, it doesn't matter which one is a over and b over. That doesn't matter. So I'm just working with this over here. A times the other divisor times x minus 1 plus b times x minus 5, that has to equal negative 8x plus 24. That divisor, that dividend from up here. That 5 is throwing me off there. So first thing, I'm going to let x equal 1. So a times 1 minus 1 is 0, plus b times 1 minus 5 is negative 4, equals negative 8 times 1 is negative 8. Negative 8 plus 24 is 16. So negative 4b equals 16. b equals negative 4. Okay, now we're going to go back. We're going to cancel off the x's. So what number makes that equal 0? And that'd be 5. So x equals 5. A times 5 minus 1 is 4. Plus b times 5 minus 5 is 0. Equals negative 8 times 5 is negative 40. Negative 40 plus 24 would be negative 16 again. Yep. So we get 4a equals negative 16. So a is also negative 4. So they're both negative 4. So our answer, we go back up to here, our answer for this would be negative 2 plus negative 4 over x minus 5 plus negative 4 over x minus 1. Okay? There would be that answer for that top one. Those negative signs you can move to the front and change this to a minus. So it can be negative 2 minus 4 over x minus 5 minus 4 over x minus 1. That's okay. Okay, 2x squared minus 9x minus 10. Go back. 2x squared minus 9x minus 10 over x squared minus 5x. Over x squared minus 5x. So I got to take x squared minus 5x into 2x squared minus 9x minus 10. So I take 2x squared over x squared, 2x squared over x squared. That gives me a 2 again, so that goes up there. Take that times x squared minus 5x, so I get 2x squared minus 10x. Change your signs, because we're subtracting, those cancel. We get x minus 10. So we're at 2 plus x minus 10 over x squared minus 5x. Now our numerator, it has a smaller degree than our denominator. So that means 2 plus, this is x times x minus 5, a over x plus b over x minus 5. So a times my other denominator, x minus 5, plus b times x has to equal x minus 10. So first I'll let x equal 5. So that's a times 0 plus 5b equals 5 minus 10, which is negative 5. So b equals a negative 1. Now I come back. In order for the b to cancel off, x has to equal 0. So this is a times negative 5 plus b times 0 equals 0 minus 10, which is negative 10. So negative 5a equals negative 10, and a equals 2. So our final answer would be 2 plus a over x, so 2 plus 2 over x, plus b over x minus 5, so plus negative 1 over x minus 5. So that'd be your final one. Okay? So that's it that we're going to cover for now. These can get a little bit more involved, but this will give you just a little bit introduction. I wouldn't want to, I am cutting back on this a little bit, quite a bit too. So let me know if you have any questions. You guys are doing a really good job of asking those when they come up. Most of you are, at least. Let me know what I can do to help you. And good luck. Very proud of each one of you. Have a wonderful summer. And good luck in college, Luke and Dylan, next year when you get there. And we will see the rest of you this fall, hopefully.